Welcome to another Refrigeration Mentor podcast. I'm your host, Trevor Matthews, and today we have another great guest on CO2 Mondays, a good friend of mine, Francois Aucoin. He's the Director of Engineering for a company called Systems LMP, and I believe they're called now Evapco LMP, recently been purchased. And me and Francois go way back for many years. We trained together, we worked alongside each other for many, many years, and we have a huge passion for training, and both of us have been involved in CO2 for many, many years. And we're going to be diving into some of the products that he's been working on and developing. He has a big team now underneath him, and I'm excited to learn a little bit more about what's going on with Francois. Francois, welcome to CO2 Mondays with Trevor. How you doing?
Thank you, Trevor. I'm doing well. Glad to be there. Glad to be here.
Awesome. Why don't you give the audience a little bit about your background in refrigeration and CO2?
So, my background. So, I'm a professional engineer. Graduated long time ago, 1990, in Polytechnic. 1992 for my master degree in physics. Then worked a few years. I started with a refrigeration contractor as a project engineer or engineer for the contractor. Then I went on to move for manager of refrigeration and energy and store planning for supermarket chain in Montreal, Metro Richelieu. This is where we first learn about CO2 in 2000, 2001, where the government of Canada made a big forum in Montreal and gathered main companies, Metro, Sobeys, IGA, Provigo, people from the industry with a lot. Also, LMP at the time was there, and they started to talk about CO2. So first time I was learning about CO2 was in 2000, 2001.
Wow.
Yeah,
That's a long time, and it came a long way since then. So
it came
2000,
a
that's over
long.
20 years.
It definitely came a long way. Now we were, to say the least, I would call that reluctant, but questioning, apprehensive. What exactly? Well, number one thing is something new. So if it's new, oh boy, that's it shakes a little bit when it's new. But anyway, so obviously in Montreal, then there was the very interesting situation where there was some end users and an OEM that decided to go and develop with the CO2. There were some grants at the time, and they started to develop. After I left Metro, I joined Emerson on the retail solution. I was project engineer for the controls. Most people know us as CPC. So I was in charge for the CPC product line for engineering in Canada and also in the US. And through those years, I was brought to work with CO2. Now, by the time CO2 was picking up, there were OEMs starting to develop and use CO2. And so there was a few OEMs. One of them, of course, being System LMP, which is a company I am now. I've been starting to work with LMP during my Metro days. They were building synthetic, but started to introduce CO2 into their portfolio in around 2010. And as the regulations led toward the elimination of HFC, CO2 took a bigger place into the market. As it took a bigger place, contractors, OEMs started to, had masterized the use of CO2, get a better understanding. As Emerson project engineer, I was brought to work with some of those OEM to adapt the controls platform to work with a CO2 rack. And there was a big learning curve for all of us, how to work with this gas, even though the fundamentals are the same. Thermodynamics, refrigeration cycle, it's the same. However, CO2 has some very particularities, especially with the triple point being high, the critical point being low. That means that the range of pressure temperature is totally different than when synthetic. And we learned to work with that both on a safety perspective, uh, both on the control perspective. Uh, exactly. So we learned a lot. And so System LMP has been working with CO2 for the last 10, 12 years. And for the last 2 years, we are strictly doing CO2 projects. We have completely abandoned HFC, only dedicated to CO2, and we are doing both industrial and commercials. We started with commercial supermarkets, but now CO2 is getting into the more and more into the industrial, small industrial. There's still going to be a place for ammonia on the bigger projects, but CO2 is attracting more and more attention from facility managers as an alternative choice to ammonia where possible.
Yeah, and we I've definitely seen that last week when we were at Chilventa. We actually, me and Francois were able to meet up while we were there. But you'll see these compressor manufacturers making bigger and bigger compressors for CO2, and that's going to have a good healthy competition with ammonia, because I don't think, as you just said it, ammonia is not going to go anywhere because it's probably it is the best refrigerant out there, and I never worked with ammonia myself, but I liked it. I like talking with the guys that are industrial guys because it is a very efficient refrigerant. So you just have to respect the gas. Same with CO2. You have to respect the gas itself and the system itself. Let's talk a little bit about the different types of systems you have. So I know one of them was called the Purity Rack, I believe. That was more on your commercial side, or is that commercial and industrial?
It is commercial and industrial.
Okay.
It is our branded product. Uh, that's how we label our system. Uh, of course, then the concept of the rack, whether it is commercial and industrial, is a matter of scaling it. You'll find the same equipment, the same valve, the same heat exchanger from a small commercial to a large industrial, except on an industrial, it is scaled to consequently to be able to deliver that amount of tonnage for industrial. But the main difference between industrial and commercial, one of the differences, many of, and I don't want to extend too much, but one of the key difference is the capacity of the system, of course. Industrial will require much more capacity. However, in industrial, you'll find that there's more load, but less circuit. So we're talking more about warehouses. You don't have cases of, obviously, there's no public. So we do a lot of system called the Purity Plus. We also do, so we have done for commercial. So let's go into commercial. So we do both indoor and outdoor. For the major supermarket chains in North America, we're starting now to deliver even in Costa Rica. So it's in Central America, so South America. So we're venturing way down south, and we can talk about it a little bit later. In the industrial, we have the standard DX system. We also have CO2 recirculated, which is the equivalent of ammonia circulated, where the compressor is going to be pumping from the receiver and pumping the vapor, and you basically have a pump feeding liquid CO2 to the evaporators, and that liquid's coming back into the receiver, and the compressors are pumping the vapor, very, very similar to an ammonia recirculated system. And we have done those systems also. We've produced many chillers using CO2. That is more intended for the food processing, plastic, food processing, any industry that requires chilled glycol. And we have done those again with a lot of success using CO2. There's always some particularities in using those different systems. The control piece also is extremely important in controlling a CO2 rack. that's a crucial part.
Yeah. And I know we had many conversations about this over the years as you helped develop a lot of the different control systems and working with the different manufacturers to really fine tune stuff. Because that's really what it is getting down to that fine tuning, where when I talk to a lot of technicians, you need to understand the control platform, but you really need to understand how all the components work together, because something could be happening in the system, but it's from a parameter from a totally different controller that's affecting this side of the system. Uh, when we talk about the designs that you guys do, I know you guys have hundreds and hundreds of installation. I know on the website it says over 355 transcritical systems installed and running right now. Uh, right now, you're running a team of dozens of engineers. What are some of the projects that you're trying to tackle? Like you just said, you're working down in South America or Central America trying to install systems. Like, what are some of the designs? Are you trying to make the designs you have more efficient, expand the brand throughout North America? What are some of the projects you're working on right now?
Okay, so we have our commercial line, which goes to the, like I said, regular, not the most common supermarket chains in Canada and North America. Those tend to be more conservative, not I would say conservative, but again, all our systems are based on the same architecture, typically where we have our compressors, suction accumulators, heat exchangers, oil management control. We have our patented things that we implement into our systems, and they all get it. So we have our commercial team focusing on it. Then our system, we're also developing right now a new solution for industrial to be more effective in terms of construction, in terms of maintenance, servicing. As far as efficiency, though there's always improvement that can be done, but we have a system that has been proven to be very, very effective, very stable. And the key thing to stabilization is we've masterized how to manage the oil into the system by using so we depressurize the oil to an IDAC. So that has proven to be very, very effective by injecting oil at a lower pressure into the compressors rather than splashing it at a high pressure. So by properly managing your oil into the system, that is also key to the success for the system. We also
let's talk about that a little bit, because I think that's really important. This is all about a control strategy now, the proper control strategy when you're doing your oil management. And so you said that you do low pressure oil management. So do you bypass some of the pressure into the flash tank? How does it actually work? Like, how does the control on the oil management work on that side instead of blowing?
Okay, so at a high level, we know that the oil are captured from the discharge gases going to the oil separator, going back to the oil reserve, which is at roughly discharge pressure, pretty high. Mm-hmm. Then we take the oil coming out of the reserve, going through a IDAC valve controller, which will depressurize the oil and lower the pressure of the oil before injecting the oil into the oil management OMC. So it is not a pulse, it is constant. So we're constantly lowering the pressure of the oil before injecting into the compressor. Instead of going from the oil reserve directly to the oil management system of the compressor. So instead of going from the reserve to the compressor, we go through a depressurizing valve.
Okay. And so that reduces that pressure in your reservoir.
Exactly. That doesn't reduce in the reservoir, reduces after that valve.
After the valve, okay. Pressure reducing valve.
Pressure reducing. And you can see it as a pressure reducing valve.
Would that be an electronic valve, I'm assuming?
That's mechanic. It's all mechanically adjusted.
Okay. Okay.
Yeah, and so what?
what pressure would you want that to be going down to? Is it a specific pressure that you're looking
Yeah,
for?
yes, we pressurize it around, the oil is injected around 600 pounds, 650 pounds,
Okay, perfect.
roughly 700 pounds. So there's a differential rather than injecting around 900 to 1,000 psi. We remove about 200 or 300 pounds of that pressure before injecting.
Yeah. Excellent. So, and this is all done through the control systems. What control systems do you guys use? I know prevalent here in Canada for CO2 is microthermal, but
Yes.
do you guys use other control systems as well?
Yeah, we have used, yeah, so the predominant one in Canada has been microthermal. Again, back, and we go way back to 2000 at that, when the CO2 forum occurred, where microthermal being material based, they started to develop locally with local OEMs for CO2. So they have 20 plus years of experience with CO2, and they have done a great job into developing as the OEMs were learning about CO2. Microthermal was basically across the street developing with them. So they have developed a very good solution for CO2, listening to the OEMs and then adapting their controls to the needs of the OEMs. And also, one thing you'll know that so most OEMs in the CO2 have other little special ways of doing things. Uh, whether it's Zero Zone, Hill Phoenix, Carnot, there's all great systems. We all have our special recipe that we apply. And Microthermo has done a good job into learning and understanding and implementing into their software and hardware the requirements of each OEM. Now we do work, most of our projects, yes, have been with Microthermo. However, as an OEM, we don't restrict ourselves to any components. Therefore, we have done a lot of projects with Emerson, whether it was the E2 platform or now the new E3 platform. So we have done projects. We've actually launched our first E3 projects in the States, which is fairly new because the E3 control platform is fairly new. But I had the advantage of been working with that platform for the last 5 years and working with CO2. So I was able to adapt pretty well the E3.
Yeah, that helps. That,
Yeah, that definitely helps.
yeah.
Definitely helps.
Yeah, no, that's good. So that's
Uh,
good because I see that's a big thing about conversations I have with technicians. I even talked with one today, and he was saying that, you know, I know a lot of the HFC microthermal systems, but when we start to get into the newer revisions with CO2, there's a learning curve from that. Can you talk a little bit about that for the technicians who work a lot on HFC microthermal going into these new revisions and some of the tips that you may be able to give them to um, help them better succeed when they're working on your systems?
okay, so it is important when you're working on a system, is really you need to start by understanding the mechanic of the system. Before you understand the controls, you have to understand why do we put a valve at a certain location? What is the function of that valve? What now, as I said, it's a refrigeration cycle, refrigeration rack, whether it's CO2, ammonia, or any gas, it is the same concept, thermodynamics. However, we all have our special way of doing things. So the mechanic has to understand the PNID of that rack, understand the purpose of that component and what it is meant to do. After that, once you understand it, then yes, you do have to understand the controls. How are we controlling that component? And the third is how that component is interacting with other components in the system, because you've said it in the beginning, that ripple effect, one component by malfunction does not function properly will have ripple effect to other components. And it's very important to understand that you're looking at a system. You have to understand the system globally, as well as understand the individual components. A difference with CO2 as opposed to HFC is that in an HFC rack or ammonia, there's a lot of mechanical valves, mechanical devices. We know and we understand that. However, the the CO2 gas does not allow much the use of mechanical devices due to the speed of reaction and also to the wide range of pressure that CO2 has, going from 200 pounds all the way to 1,200 pounds at some point. So there's a big span of conditions. For that, you'll see a lot more controls on a CO2 rack than on an HFC rack. And definitely for a mechanic to properly operate and manage a CO2 facility, you do need a good understanding of the control platform, whether it is the microthermo, the Emerson, or the Danfoss, or the new one, the Carrel, or whatever the control platform it is. Very important to well understand how these platforms operate, how to navigate. It's not just a matter of going into a facility, acknowledging the alarm, and hoping that it goes away before the weekend. It's a little bit more complex and in-depth than that.
Yeah. No, but I like what you said. You know, there's multiple factors, and right off the bat, a lot of people come to me when they're looking for training. Oh, I need control trainings. I need to understand the controls. But like you said, understand those fundamentals of CO2 is hands off the first thing you should know, because it acts differently than an HFC system or synthetic system, and you want to understand that. Then you get into the P&ID, and I really like that, is because I think more technicians need to understand the P&ID and how it works. And I keep telling technicians I train is like, I'm a better refrigeration technician now that I'm learning about the engineering behind it. Because I used to curse engineers all the time. Why did they do it like this? Why did they do it like that? But I didn't know the behind the scenes of why they're doing something. And now understanding the engineering side is actually making me a better troubleshooter. And when you understand that P&ID loop, diagram, and then each component, like you said, this component is here. Why is it here? What does it do? And how does it affect the next one? And then you get into the control side. I like that. I like that staged approach to learning CO2.
It is, because just knowing the controls without knowing what the valve's supposed to do, you cannot effectively operate and manage it and put a set point. Okay, I'll give you a set point of 55. Well, is 55 make sense or not? If you have to understand the system to know, and is that valve supposed to act fast, not fast? Okay, so you know you can change PID. Okay, PID is basically the speed of reaction of that valve, but do you want that valve to operate fast, slow, under what conditions? We have CDS valve as like a stepper valve. Now, whether we use a Sporlan, and again, you also have to understand that if you're using Sporlan versus Danfoss, even though the valve is doing the same function, the valve will have different, not behavior, but they will have different step rate, different speed of reaction. So understanding also the components that you're working with, and now you need to adapt your program according to what you want to do with that valve and how it's going to react, understanding the valve. So it's total. So you have to understand components, purpose, and the controls, definitely.
Yeah. Now, I really like that too, because I was talking to a few control manufacturers, and what happens a lot of times, if a control, say, burns out or something happens to it, it fails, that technician taking in and putting in a new controller, they need to understand that there was parameters put in there, and I've seen it even when I worked at Emerson, where people just put a controller in and think, oh, it automatically works. No, there's certain steps that you need to do and set it up because, for example, a step rate could be different, and if you put that in wrong, it's not going to work properly.
In our, and I've seen that from again my past experience, but once a system is installed mechanically, so you set up you do the installation, you do all the welding, you mount all the pipes, and you do your refrigeration 101, welding, piping, adding oil, validating your pressure, vacuum. Once a facility has been operating, 90% of your troubleshooting will go through the controls, and maybe even 95%. As I said, I've given a lot of classes for control, as you know. The first thing that you do when there's a problem, and I always, so the mechanic walks into a room, the first thing you should do is, okay, understand the system you're facing, then go through the controls and see the alarm log. So your first task will go to look at what are the alarm registries, what caused the system to fail, pull some graphics. So your resolution may be mechanical. You may change a mechanical part, but in order to identify which part you need to change, your troubleshooting will go through the use of the controls. And to properly understand which component fails, if it is a failed component, you need to understand exactly what is that component doing, what are the signals through the control system that indicates that this is a failure. So controls and mechanics they're connected. And as I said, after the system has been running for 6 months, a year, there's not many mechanics that will be able to properly maintain a system without a good knowledge of the controls.
Yeah, and I agree with that. And this is where technicians need to step up and take their time to look how those systems are designed, ask questions. I think that's a big thing. I seen on your guys' website that you guys do trainings with your customers. I'm assuming that you guys send guys out to do the startups for any rack that you guys have. You want to talk a little bit about that and your process of working with the contractor when you guys have a new rack installation?
Yes. So for all the projects, again, it is an option that we offer, but we greatly recommend. So we have a team of 4 qualified mechanic working with us that have been with the company for many years, and again have developed an expertise in CO2. So when we're doing a new facility has been built up, those technician will be sent out to work with the installing contractor at the startup phase. Again, we are not doing the startup for the contractor. It is not a startup services, it is a startup assistance. We believe in teaching. We strongly believe in educating contractors to be better with our system, with our equipment. We want them to understand how to install, how to operate it. And the best for that is that during the startup phase, we're assisting them both on the mechanical, so how to charge a system, how to put the oil, do an oil change, what are the safety precautions that you need to take before opening up and changing dryers, for instance. What valve should you close? Make sure that you need to relieve all the pressures. Where are the pressure relief access valves? So all of that. So we teach the installing contractor all the safeties, how to operate the rack. Uh, we cover we cover the controls, how the machine operates. Again, it is not a control class that we're giving. We are going into surface. If contractor wants to learn more, we will encourage them to register with a different control companies for classes.
Mm.
But we will assist them, and it's a week service, 1 or 2 week service during startup. Again, the main thing is that when we leave the facility, of course, the rack is running. It is operational, and the contractor has confidence in being able to operate that system. That's the key thing, the key takeaway that we want for a startup assistance, that the contractor has. We want to remove the fear. Uh,
Yeah.
some of them have done many CO2 projects. Some of them is going to be their first one. So we want to remove the fear.
Yeah, and I like that though. I think it's really important that uh, as as the startup assistance, because you really need to have them do the work. And I've seen this before where OEMs or trainers or educators, whatever it is, and even lead journeymen and technician trying to teach younger guys, they'll just get in there and do it. Oh, this is how you do it here. This is how you do it. But really, that person is not really learning unless they're doing it. And I like that strategy is having them do the work to get it done. And that's how you learn. You know, you learn by doing.
Uh, Yes, exactly. I mean, ultimately, our service technician are there to support, and not the opposite. So I'm not the startup guy. The contractor is. We're there to help,
Yeah.
to answer the questions, to go over the machine, and that, like I said, or now and there are some contractors that we have been that we don't do any more startup with anymore. We've been there before. We've been there with them on the first few installations. And usually, what I say is that, yeah, the first startup, we should be very active. The first time that we work with a contractor, uh, we should be very active and to probably a little bit more hands-on. The second project, we should basically be mostly looking over the shoulder, making sure that he understands. And the third project, when we do startup, that contractor should have enough, uh, should be qualified, and we're there really as a not a not a service, but backup for a few questions. After 3, 4 startup assistance, contractor we believe should be able to pursue uh, on their own. Again, that really depends on the contractor, the personnel. We understand that a contractor that has 50 technicians uh, is not going to gather 50 people in a mechanical room to do a startup.
Yeah.
But what we want the ultimate goal is that every field technician has enough knowledge to be able to walk into a mechanical room, sees a LMP purity rack. He has a method. He understands now. He won't be afraid of working and learning about the machine. He may be not the expert. He may not know all the details, but he will have the proper tools to be able to troubleshoot the problem and know how to identify the problem. Now, the key thing, half the battle, I say, is identifying where is the problem. Even more than half, maybe even 3/4. As a mechanic, you walk into a mechanical room, there's a problem. Identifying the root cause of your problem is crucial. That's 75% of the battle. After you've identified where the problem is, what it is, then you have all the expertise as a mechanic to make the corrections. But you have to understand where the problem is.
Yeah. Okay, so I know you've done tons of field support over the years, and you help your team out there. What are some of the things that you've seen that you would like? you would like the knowledge level to grow in the refrigeration in your first CO2 because you have a lot of equipment out there, and I'm sure there you see similar problems maybe happening over time that could be rectified, maybe from not pulling proper evacuation, pressure tests. I'm not sure what it is, but what are some of the things that your team sees that you would like other technicians out there when they start to work or serve as a purity rack to have that idea to make sure they look for that?
Uh, there's a that's
So it's a big question.
a big question. I think that regard it is CO2. So again, we'll go back to mechanic 101. Ensure that your weldings are well done, that your slopes toward the mechanical rooms are are done. The slope. Uh, the so the refrigeration, the basic still needs to be is still there. It's no different. Uh, the charging though, what's also important as well is definitely understanding the safety specification of CO2. Charge vapor, instead of charging liquid, charge vapor. These few differences with HFC. Understand, as I said, understanding that you need to build your pressure first, but a good vacuum will definitely be a must. It's a key to success.
Mhm.
Understanding also how to charge your system properly. Uh, and gas cooler installation also, well, understanding how to operate the gas cooler, whether you're using an adiabatic or a air cool, ensuring that the gas cooler is clean. And before starting your CO2 system, ensure that you do a review of all the components. Make sure that you don't have a reverse phase. Ensure that your gas cooler fans are turning in the right directions. That you don't have those little, mistakes. What we see also is that with HFC, HFC has a speed of reaction a little bit slower, so your pressure will rise, but you will seldom blow up the relief. When CO2, the reaction of that gas is extremely fast, and it won't take long that if something goes wrong, that you blow the charge. You open up the relief, and you lose your charge. So it is important before starting up the system that you will commission twice that system, ensuring that everything is working. I even do almost like let's say a dry run, a simulation that all the valves are working, are responding, that all your gas cooler is responding to the controls. Do a good review, commissioning of all the controls, ensuring that all the sensors, all the outputs are reading, and outputs are you're able to override. That everything is responding. So I would
Awesome.
say,
Yeah, and that's very important. It's like I talk to a lot of people. It's like doing the same steps, but just making sure you double check everything. It's very important, especially with CO2. So let's get into the design of the system. Is it the same design? Do you guys use hot gas defrost on all your systems? Is it electric defrost? Like in your design, do you have air conditioning? Do you have heat reclaim recovery? Is it options on your system? So how do you guys associate that? Is it depending on what the customer actually wants or needs, or um, it depends on the project, I guess?
it will depend on the project. So definitely, we have masterized the use of hot gas defrost with our system by the use of regulating valve, both on the ejection and on the return. So we're able to modulate. And we have done hot gas defrost for the last 10 years, and it's a reverse cycle, exactly the same as what you'll commonly find in the HFC system. Different pressure, I do agree. I do realize it's different pressure, but it is the same reverse cycle. Again, going to the PNID and understanding how it is made, because we have two modulating valves to control the flow of that hot gas going through the evaporator. So we have hot gas defrost, commonly used, and again, will be very driven by the customer request, whether they want to use electric or hot gas. We have low pressure defrost, which will defrost around 575 pounds, 560 to 575 pounds. But you also have a high pressure defrost, where we will take discharge gas, lower the pressure through that modulating valve, and then inject it around 650, 675. That high pressure defrost will mainly be used in industrial applications where you have a very big evaporator, like a 20-ton evaporator that you need to defrost. It's become more efficient using the high pressure defrost. And if customer wants it, of course, off time, that's always present. Now, a lot of customers will want to go electric defrost for the simplicity, for a bit, definitely less components at the rack, at the cases. Loop pipe, electric defrost also allows you to do a 2-pipe loop piping. So a lot of facility, instead of using home run, because with hot gas defrost, your most commonly is to do home run for your circuits. Because we do a reverse cycle, of course, you cannot do a loop pipe wall. Otherwise, we would have, there's some few designs that we can alternate, but most common supermarket will use hot gas with home runs. So suction and liquid going to a few cases. Electrical defrost, a lot of customers will tend to use the loop piping, where you have a common liquid, a common suction, and then you branch off to go and feed groups of cases or evaporators. We've done now, again, we're able to adapt to the customer need. We've also started to combine loop piping with hot gas defrost, which is a four loop system. So you have a liquid, a suction, and then you will have a hot gas injection and a hot gas return. So you basically have 4 pipes going into the facility, and then you will have a valve station at every evaporator to manage either refrigeration or hot gas.
Awesome. So that's pretty cool, the 4-pipe system. Let's talk about just a little bit about the high pressure one. You're using high pressure mostly in the industrial side. Is that because the coils are so big, you get more mass flow when you're running it at 650, 675?
Yeah,
because the coils are bigger?
The coils are bigger. There's more mass to move. If we would defrost at a lower pressure, it would just lengthen the defrost. We would definitely defrost, of course, because there's also a lot of heat contained into the CO2. CO2 gases on the discharge gas is very warm. But both two different concepts though. But yeah, what drives the decision to go with high speed will be the size of the evaporator to be able to shorten the defrost time.
Nice.
Heat recovery. Also, you've mentioned heat recovery. Again, an option based on customers. Now, it is an option, but it is also, it is a source of energy that you've already paid for that gas to be hot, so might as well redirect it to using for either heating glycol to heat up a slab under floor freezer. You can we have a question here. How is the flash tank affected by the use of hot gas defrost?
The size of it. So do you have a bigger, I guess they mean, do you have a bigger flash tank?
Yes. So when we do hot gas defrost, of course, you need to be able to, how you say that, flush that liquid. You need to be able to empty up a full circuit into the flash tank. Definitely. So yes, hot gas defrost may have an impact on the size of the flash tank, because yes, you want to empty up a complete circuit. So it is very important that we know the quantity of liquid into the lines and an evaporator. So we will assume that we're only defrosting one circuit at a time, and then all that amount of CO2 liquid needs to go somewhere. So the flash tank is sized accordingly. So yes, you'll find a trend to have bigger flash tank into the hot gas systems, definitely.
Awesome. That's good. That's something that I didn't know. So I'm always learning. Thanks for the question. That's
Oh,
fantastic. And so you said you guys do heat recovery depending
yes.
on your customer. And what I like about this is because CO2 is very efficient and you can get a lot of heat out of the CO2. And I was doing a training last week or 2 weeks ago where I was talking to a technician and he said, my customer turned off their heat reclaim because this is a cost them too much money. And I was thinking, I don't know if they don't understand how, unless they're getting power for free, how they're just
Uh,
wasting that heat. Like you said, you're just throwing that heat away in the air if they already have it. So they asked them actually, the customer asked them to turn off the heat reclaim.
well, I mean, I don't believe into driving your pressure to very high to produce more heat. I mean, there's a balance.
Mm-hmm.
Uh, you have to be efficient. So at one point, uh, running your compressors, loading your compressors strictly to gain more heat may not be effective. But using the heat available without forcing the system to operate, you're already using energy to produce refrigeration, and you do have a counter, you have that heat available. Therefore, that's where we will recommend that every facility should have heat reclaim. Now, whether you want to do air heat reclaim direct, hot water heat reclaim, which is great because now you can do thermal storage. Uh, Using in freezer applications, you will mostly industrial will have the slab hot glycol for slabs. Again, using heat reclaim, yeah, I do realize that going through a plate exchanger or shell and tube to heat up glycol or hot water, you do lose a little bit of efficiency compared to a direct air, but you can also do thermal storage, which basically, in my opinion, will counter offset the loss of benefits. Because yes, if you're strictly doing direct air exchange, when you don't need any heat reclaim, if there's nowhere for that heat to go, then it will definitely go to the gas cooler, which is wasted. So if you do the total, uh, if you consider that hot water you'll need it 24/7, and we also have many customers that will combine air and hot water heat reclaim. Therefore, with a priority, if you need air, you're going to the air. If their heat reclaim is not needed, then continue warming up your water. We also have our patented Purity Plus heat recovery, which is unique to LMP, where we will have heat reclaim on the discharge gas, but we will also have a second loop of heat recovery after the gas cooler. Now, these are cooler gases, but there's still energy contained in them. So the gases coming out of the gas cooler are still warm. They're not hot, but they're warm. So what we're doing is that we are redirecting those gases directly into the heat, into the air system for dehumidification reheat.
Mm.
During the dehumidification mode, there's little heat required, not as much as heating. So we can use that heat, residual heat after the gas cooler, and redirect it into the dehumidification system for reheat purposes. And we have seen very, very good results in using that method when we have hot and humid days in the summer, going to the 95 degrees Fahrenheit. And by redirecting those gases through the system for dehumidification, we were able to maintain our temperatures and our system, they were in transcritical, yes, but barely into the transcritical.
And so this would have, I guess, after the gas cooler, you'll have a couple of three-way valves, I'm assuming, to divert
Correct.
into another unit, which would be like an big air dehumidification air handler, and then back into the valve, then
Correct.
into your high pressure valve before
Correct.
the, awesome. Okay.
Correct. So it's kind of a two-stage heat reclaim. One is before the gas cooler, one is after.
Cool.
And it allows
I
us
haven't
to,
seen that before.
no, it's our patented Purity Plus system. We can,
Awesome. I'll have to look that up. That is super cool. So I'd love to see some more of those PNIDs of your design, because that really, for me now, after looking at more and more PNIDs, the drawings of where all the valves, all the components are, and if you're a technician out there, or if you're looking to learn more about CO2, that's where you start looking at those diagrams and understanding what direction that gas is going. So it's leaving the compressors into the discharge header, into, as it starts to travel, it goes up into a valve, is it going to heat reclaim, and what direction, and you know what I mean? So that's the important things. And like Francois said earlier, understand those fundamentals of the mechanics is so, so important. Francois, this has been awesome. I learned so much. Where can people learn more about Systems LMB, learn more about Francois if they want to get in touch?
well, on our website, the System LMP, Evapco System LMP. Now, LMP was a private-owned company. We got purchased by Evapco, the Evapco Inc., which is the company based out of County Town, which is just outside of Baltimore. So we have our website, Evapco LMP, and there's some contacts there that they can follow. They can contact us by email or phone, and definitely we'll be glad to help them. We also have, so we have a few, again, on our website, they'll be able to find the contacts. And if they want to learn more about the system, we offer training on our systems. We can assist customers into their design, any sort of that we can help them.
Awesome. I love that. I love that. Yeah, definitely go check out the website, evapcolmp.ca. Go into documentations. I just looked it up, then you can get their purity rack manual, so you can look at that, kind of get an idea of what type of system they have. I want to thank everyone for taking the time to hang out with us today. If you like this podcast, please share it with people. This is how more people learn about it, learn about CO2. Free information from the experts all around the world. Francois, thank you so much, and I'll see everyone at the next CO2 Monday with Trevor.
Trevor, it's been my pleasure and an honor to be part of that podcast.
Hey, I want to thank you for taking the time to watch this video. I hope you got something out of it, something that you can use in your daily life. If you like this video, hit the thumbs up button, hit the subscribe button, and click the bell button, because when you do click the bell button, it will notify you anytime new videos are released. Also, check out the Refrigeration Mentor webpage at refrigerationmentor.com, where I'll have all the different trainings, upcoming events, the different podcasts I've been on, as well as the Refrigeration Mentor podcast. If you want to check that out on Apple, Spotify, Google, any service provider of your choice. Super excited to see you at the next video. Now let's get a conversation going.